The unique Triton Mitre gauge has an adjustment range from 0 to 45 in both directions. And because you can use it in either slot in the table and either way around, you'll always find a position where you can get the wood into the right angle for the cut, and you've got a sandpaper face close to your saw blade for maximum backup support at the point where you're doing the cut. Now, the most common angle is 45 degrees, so let's do that first. I've set the gauge exactly at 45 degrees according to scale. Then take a straight piece of scrap, preferably a piece that's not going to rock on the table. This has got a little bit of rock, but it'll probably do for the test. It's a bit better that way. And make sure the edge, which is against the upstand of the mitre gauge, is straight. Now, you'll have to grip the wood fairly firmly because there is a tendency during mitre cuts for the wood to creep during the cut, so grip it firmly against the sandpaper, safety guard lowered and hands out of the way. And I'll be keeping some downward pressure on the mitre gauge to make sure it stays in contact with its guiding V-grooves. And then line up the piece, grip it firmly and make the cut. You'll always find a tiny little artefact there, a little bit that breaks rather than cutting through. Trim that off with a utility knife, clean off any uncut fibres, and then put the joint together. Now, you can use any square to check this, but you can also use a built-in square in the mitre gauge because these two faces are manufactured exactly at 90 degrees to each other. So you can hold the pieces against the faces and then close up the mitre joint and have a good look at it. Now, if you've got any error across the cut up there, any gaping there, then your saw blade is not quite square to the table. Make that small adjustment. Bear in mind the error that you see there is doubled what the actual error in the saw blade is because you're putting the two pieces together. And then check out the cut along the cut. And again, if you've got an error, you might have to make a tiny adjustment to the setting of your gauge because any error will be seen as double the actual setting error because you're putting the off cut against the main piece, doubling your error. And if you've got any gap in the middle of the cut, for example, that indicates that the wood actually moved slightly during the cut. It crept, so recut it. It is always a very good idea with mitre cuts that you do a cut and then a shaving cut. Just take off, say, 1 millimetre or so just to make the saw blade not work quite as hard and give you a perfect result there. That built-in right angle in the mitre gauge is really useful for doing right angle joins. All you do is dial up 45 degrees on the alternate scale, lock it in position, and do check that that is exactly 45 degrees by recutting this piece, just a shaving cut off this face, and then recutting this piece again off the same face, putting the two pieces together and making sure they add up to 90 degrees. Then every one of your subsequent workpieces, if you put one piece in there and one piece in here, do them singly rather than together. If you cut this piece on this face, this piece on this face, gripping it firmly to the upstand like so, then these two pieces will always form a 90-degree mitre, guaranteed. Now, it's not actually essential that you have this gauge set at 45 degrees for these sort of cuts. You could be set at 44.5 and you'd still come out at a perfect right angle because this one will be 44.5, therefore this one will be 45.5. So it'll always compensate and give you a sum of 90 degrees in your two pieces. But if you're doing a picture frame, for example, a square or rectangular picture frame, then you've got 4 mitre joints, and when you put the third and the fourth pieces together, you want them to add up to a perfect mitre without any wrestling and struggling. So it is a good discipline to work at exactly 45 degrees on the gauge, even though you will be using these two faces, which give you a guaranteed 90-degree mitre in any case. Let's say you want to mitre cut 2 pieces of unequal width. Now clearly it won't be a 45-degree mitre, but you can do it, and this is how. You just line the pieces up in the orientation that they'll finally end up in, and then mark on one of the pieces where the inside of the mitre will be, and then simply take a ruler and join up the dots. Go from the mark you've just made to the outside corner of the piece of wood, and that's your cutting angle. Then, by simply moving the protractor into position, you can rest this against this face, align it by eye, and here's a little hint. Get your ruler back, put it on the pencil mark, and hold it firmly on the mark, and then use that to extend the line so that you can line up the protractor so it's exactly parallel to the slot, infill slot of the table. And then lock it at that angle. There we are, that's the cutting angle. Now, if the first piece is cut on this face and the second piece is cut off this face, I should still get a perfect 90-degree mitre. Let's see. There we are, a slight error there. This piece is slightly long in the cut, but that's just a minute adjustment of my protractor angle. When you're making frames, be they rectangular, square, hexagonal, octagonal, you'll need a number of pieces cut on an angle to exactly the same length. Well, that's where a little jig like this one comes in very handy. It's simply 2 strips of MDF screwed to the upstands of my protractor. Now, an important point here, when you're screwing these on, make sure you put some little bit of packing underneath them as you're putting the screws in. Otherwise, you might find that the wood is actually resting on the Triton Workcentre table, and that may lift the protractor up slightly out of its slot and lose the guidance of the V-grooves at the bottom of the slot. So a bit of packing in there before you screw anything onto your protractor. You may also notice that I've cut a couple of notches here so that I can lower the overhead guard and still pass through with my jig safely. The length of these is left up to you, but I wouldn't go longer than about 750 millimetres for each of these sub-fences, because they might end up becoming a little bit unwieldy in themselves. The only thing missing from this ensemble is a little stop block, just a little mitered block, which I'll clamp on like so. I've made these sub-fences just a little bit too short, but I'll demonstrate the point. And now I'm ready to cut. And cut that way, every single piece will be exactly the same length. By using the 2 faces, I was able to cut the reverse angle mitre by always holding the wood down on its flat back. You must never try and rest your wood on the Workcentre table on its contoured face. You can always find an angle position where you can rest on your flat back. And notice also how the in-cut is nice and sharp, because that was a face that was uppermost, and all the tear out is on the bottom where it doesn't matter. You'll notice that the sub-fences are attached to the protractor via these slots. Now that means that you can loosen these screws and move these sub-fences slightly one way or the other. And if you adjust it so that this sub-fence is just grazing the side of the saw blade, then you can use it to load a piece of wood in and line up a pencil mark with the edge of that sub-fence, and then through you go. That'll be a dead accurate cut right to that point there. Another good reason to use MDF sub-fences to back up your workpiece, they will reduce any tendency for splintering on the back edge, the edge which was resting against the protractor. If that's backed up with a piece of MDF hard up against the saw blade, then you'll minimise the splintering on your main piece.